Take a deep breath and allow your body to settle into the soft, supporting embrace of your bed, feeling the weight of the day simply dissolve into the mattress. As you close your eyes, let go of the world you know and prepare to journey 4.5 billion kilometers away to the farthest reaches of our solar system, to the sapphire-hued majesty of the ice giant Neptune. Here, at the very edge of the sun's influence, we find a world that is fundamentally different from the rocky shores of Earth. What is fascinating about Neptune is that it isn't just a ball of gas. Astronomers classify it as an ice giant because it is composed mostly of a hot, dense fluid of icy materials, specifically water, methane, and ammonia, sitting atop a small rocky core. As we begin our descent into the upper reaches of the Neptunian atmosphere, you might notice the temperature here is a staggering -218 degrees Celsius, the coldest in the known solar system. Yet, despite this biting cold, the air feels strangely thick and velvety, a vast blanket of 80% hydrogen and 19% helium that wraps around the planet like a heavy silken quilt. The color of this world is perhaps its most mesmerizing feature. As we drift through the high-altitude haze, the sky is a deep, immersive cobalt. This happens because the small amount of methane in the upper atmosphere, only about 1.5%, acts as a selective filter for light. Methane gas absorbs the longer, redder wavelengths of light at the 600 nanometer range and reflects the shorter, bluer wavelengths back into space. Imagine being enveloped in a shade of blue so pure, it feels like resting your eyes at the bottom of a deep, calm ocean. There is a profound stillness here, despite the fact that Neptune's internal heat causes the atmosphere to move in slow, rhythmic pulses. As we move deeper, the pressure begins to rise. But in this journey, the pressure is not a burden. It is a gentle, steady hug from the universe. Most people don't know that Neptune radiates 2.6 times more energy than it receives from the distant, dim sun. This internal warmth creates a soft, upward convection, a slow-motion dance of molecules rising from the interior. We are passing through the troposphere now, where the clouds are not made of water vapor, like they are on Earth, but of frozen methane. These clouds feel like fine, crystalline dust against the skin, silky, dry, and infinitely soft. They form in thin, wispy streaks called cirrus clouds, drifting miles above the main deck of the atmosphere. What is truly remarkable is the scale of time and space on this giant. It takes Neptune nearly 165 Earth years to complete a single orbit around the Sun. This means that seasons here last for over 40 years. Imagine a spring that lasts for 4 decades, a slow, patient unfolding of celestial cycles that makes our human worries feel fleeting and insignificant. As we sink further, we leave the frozen methane clouds behind and enter a region where the temperature begins to climb, transitioning from the frigid exterior toward the smoldering heart of the planet. We are now entering the realm of the Great Deep. At this depth, roughly 7,000 kilometers below the cloud tops, the environment undergoes a radical transformation. The atmospheric pressure has increased to approximately 200,000 times the pressure at sea level on Earth. Here, the physics of the ordinary world begin to break down, replaced by a beautiful, exotic chemistry. The methane molecules, which consist of one carbon atom bonded to 4 hydrogen atoms, find themselves under so much stress that the bonds begin to snap. It is a peaceful release of energy. The hydrogen atoms drift away, merging back into the surrounding sea of gas, leaving the carbon atoms alone. Under this immense weight, these carbon atoms seek the company of one another. They begin to cluster bonding in a very specific tetrahedral lattice structure. This is the exact moment of birth for a diamond. Here, in the dark, warm depths of the ice giant, it isn't raining water or snow. It is raining gems. These diamonds aren't the tiny specks you might find in a jeweler's shop. Because of the vast amounts of carbon available and the steady, unrelenting pressure, these crystals can grow to be centimeters or even meters across. Some may weigh millions of carats, drifting slowly downward through the mantle, like heavy, glittering hailstones in slow motion. The sound here is a low-frequency hum, the vibration of billions of atoms reorganizing themselves into perfect geometric order. Imagine the texture of these falling gems, smooth, cold to the touch, despite the rising ambient heat, and perfectly faceted by the laws of physics. They sink through the mantle, which isn't a solid rock like Earth's, but a supersonic water ocean. This is a strange state of matter where water molecules are crushed so tightly that the oxygen atoms lock into a solid lattice, while the hydrogen ions flow freely through them like a liquid. It is a warm, conductive sea, glowing with a faint internal light. As these diamonds descend, they pass through layers of increasing heat. While the surface was a frozen desert, the interior of Neptune is a different story. The temperature at these depths reaches about 2,500 Kelvin, comparable to the surface of some stars. Yet, because the pressure is so high, the diamonds do not melt. They remain solid, sinking deeper and deeper through the slushy metallic fluid of the mantle. You might wonder how we know this. Scientific experiments using high-powered lasers at laboratories, like the SLAC National Accelerator Laboratory, have actually recreated these pressures, proving that diamond rain is a physical reality on worlds like Neptune and Uranus. The sensory experience of this descent is one of profound density and richness. The air, if you can call it that, has the consistency of a thick syrup, providing a buoyant, floating sensation. There is no wind here, only the steady downward migration of the carbon crystals. The diamonds shimmer with a ghostly brilliance, catching the faint bioluminescent-like glow of the supersonic ocean. It is a world of shadows and light, of blue and silver, where the very air creates treasures. Neptune's magnetic field adds another layer to this immersive experience. Unlike Earth's magnetic field, which is aligned closely with our planet's rotation, Neptune's field is tilted at a sharp 47-degree angle and is offset from the planet's physical center. This creates a complex, wobbling magnetosphere that is 27 times more powerful than Earth's. As we descend, you can almost feel the invisible lines of magnetic force thrumming through the atmosphere, a gentle rhythmic pulsing that resonates with the core of your being. It is a cosmic heartbeat, steady and calming, guiding the diamond rain toward the center of the world. As we drift deeper into the mantle, the scale of the planet becomes even more apparent. Neptune is nearly 4 times the diameter of Earth, a vast cathedral of ice and pressure. Here, the diamonds may eventually reach a point where the heat is so intense that they finally begin to liquefy, creating oceans of liquid carbon with solid diamond icebergs floating on top. Imagine the sight of a sea made of liquid diamond, undulating with a metallic sheen under a sky that is constantly shedding new crystals. This is the hidden heart of the ice giant, a place of unimaginable wealth and beauty, tucked away in the dark, cold corners of the solar system. The chemistry of this world is a reminder of the interconnection of all things. The carbon that makes up these diamonds is the same element that forms the basis of all life on Earth. In the crushing depths of Neptune, that carbon is simply finding a different way to express itself, turning into the hardest, most brilliant substance known to man. It is a transition of state, a journey of refinement. The diamonds are not falling so much as they are settling into their rightful place, moving toward the core, where they will eventually add their mass to the planet's heavy, rocky heart. In this deep, cobalt world, there is no sense of urgency. The diamond rain has been falling for billions of years, and it will continue for billions more. It is a process as steady and reliable as the rising of the sun. As we float among these falling gems, we can feel the immense age of the planet. Neptune formed 4.5 billion years ago from the primordial gas and dust of the solar nebula. It has watched the sun age, watched the planets find their orbits, and all the while, in its secret interior, it has been quietly manufacturing diamonds in the dark. The temperature continues to rise as we approach the core, but the transition is so gradual, so smooth, that it feels like a warm bath. The pressures here are measured in the millions of atmospheres, yet there is a sense of incredible stability. In nature, extreme pressure often creates extreme beauty. Just as a piece of coal becomes a diamond, the chaos of the early solar system has been pressed into the orderly, serene blue marble we see today. Let yourself be carried by the currents of this blue world. Feel the velvety texture of the high-altitude methane clouds, the sharp, cool edges of the newborn diamonds, and the warm, thick embrace of the superionic sea. There is nothing here to disturb you, only the infinite repetition of a natural miracle. The diamond rain is a song without words, a visual symphony of geometry and light. As we continue our descent, the world becomes even more tranquil, the colors shifting from the bright cobalt of the upper clouds to a dark, regal navy, and finally to a warm, glowing amber as we approach the internal heat of the core. Every breath you take is synchronized with the slow rotation of the planet. Every heartbeat is a reflection of the magnetic pulse of the magnetosphere. You are a part of this journey, a witness to the secret alchemy of the cosmos. In the parts to come, we will explore the microscopic structures of these diamonds and the vast metallic oceans that lie even deeper. But for now, simply drift. Sink deeper into the sapphire light, feeling the gentle weight of the Neptunian atmosphere pressing away the tensions of your day, replacing them with the steady, crystalline peace of the diamond rain. Consider the way our understanding of the universe often begins not with sight, but with the quiet, rhythmic scratch of a pencil against paper. While we now envision Neptune as a vibrant azure sphere, for decades it existed only as a ghost in the equations of 19th century mathematicians. What is compelling about this history is that Neptune was the first planet ever located through mathematical prediction rather than through the lens of a telescope. In 1821, a French astronomer named Alexis Bouvard published tables of the orbit of Uranus, but he noticed something curious. The planet wasn't where it was supposed to be. It moved with a slight, inexplicable wobble, as if being tugged by an unseen hand. This gravitational pull suggested a hidden neighbor, a massive body lurking further out in the darkness of the outer solar system, 4.5 billion kilometers from our sun. By 1846, another mathematician, Urbain Le Verrier, calculated the exact coordinates of where this phantom planet should reside. He sent his findings to the Berlin Observatory, where Johann Gottfried Galle received the letter on September 23rd. That very evening, Galle pointed his telescope toward the predicted patch of sky and found Neptune within 1 degree of Le Verrier's coordinates. Within a single hour of searching, A world that had been invisible for all of human history was suddenly real. Picture the sensation of that discovery. The crisp, cool night air of Berlin, the smell of old parchment and brass, and the sudden breathtaking sight of a tiny blue disk emerging from the blackness. This world, nearly 4 times the size of Earth, had been waiting in the silence for eons. As we settle further into this narrative, notice how our perspective shifted again in August 1989, when the Voyager 2 spacecraft completed its 12-year journey to become the only human-made object to visit the ice giant. It skimmed just 4,150 kilometers above the planet's north pole, providing our first high-resolution look at the sapphire atmosphere. Voyager 2 revealed that Neptune is 1715 times the mass of Earth, a staggering weight that creates the very pressures we are exploring. It also measured the planet's gravity, which is surprisingly familiar. Despite its massive size, gravity on Neptune is only 14% stronger than what you feel on Earth right now. This is because the planet is so large that its surface is very far from its dense core, softening the pull and allowing for a gentle, buoyant atmosphere that feels remarkably supportive. The concept of the diamond rain itself didn't emerge until 1981, when a physicist named Marvin Ross published a groundbreaking paper in the journal Nature. He proposed that the extreme heat and pressure within the ice giants could strip the carbon from methane molecules, compressing them into solid crystals. At the time, this was a radical idea, a piece of theoretical poetry. But decades later, modern scientists at the SLAC National Accelerator Laboratory used the Matter in Extreme Conditions instrument to recreate the interior of Neptune right here on Earth. They took simple polystyrene, the same white cellular foam often used in packaging, and hit it with high-powered optical lasers. Because polystyrene is made of carbon and hydrogen, just like the methane on Neptune, the lasers were able to simulate pressures of 150 gigapascals. That is roughly 1.5 million times the atmospheric pressure at Earth's sea level. Under these conditions, the researchers watched in real time as the carbon atoms rearranged themselves into nanodiamonds in just a few billionths of a second. This laboratory confirmation transforms the diamond rain from a myth into a tangible reality. Imagine the sound of those lasers, a sharp, energetic pulse followed by the profound silence of a crystal forming. In the deep interior of the planet, where temperatures can reach 5,000 degrees Celsius, this process happens continuously. It is a slow, methodical refinement of matter. The atmosphere isn't just hydrogen and helium. It also contains trace amounts of more complex hydrocarbons, like ethane, acetylene, and diacetylene. These molecules are the building blocks of the rain, drifting through the stratosphere like microscopic seeds, waiting for the pressure to turn them into something spectacular. As you breathe in the cool, imagined air of this distant world, consider the rings of Neptune, which were only fully understood in 1984 through a process called stellar occultation. Astronomers watched as the planet passed in front of a distant star, noticing that the star's light flickered as it was blocked by thin ribbons of dust. Voyager 2 later confirmed 5 distinct rings named after the astronomers who discovered the planet: Gall, Leverrier, Lassell, Arago, and Adams. These rings are not the broad, icy sheets of Saturn, but are dark and dusty, coated in radiation-processed organic silicates that give them a charcoal-like texture. If you could touch them, they would feel like fine, velvety soot, a stark contrast to the brilliant diamonds falling far below. The outermost ring, the Adams ring, possesses 5 strange clumps of dust, known as arcs. These arcs were named Liberté, Égalité, Fraternité, and courage. What's noteworthy is that, according to the laws of motion, these clumps should spread out evenly around the ring, yet they stay bunched together. Scientists believe the gravitational influence of a small moon, named Galatea, acts like a cosmic shepherd, nudging the dust back into place and maintaining these beautiful curved structures. It is a delicate balance of forces, a rhythmic adjustment that keeps the rings in a state of perpetual, quiet order. At this very moment, envision the sheer distance of this world. Neptune sits 30 times farther from the Sun than Earth. Because of this vast gap, the sunlight that reaches the cloud tops is 900 times dimmer than it is on a bright afternoon at home. It takes 4 hours and 6 minutes for a single photon of light to travel from the Sun to Neptune. By the time it arrives, it is no longer a warm caress, but a faint silvery glow, casting long, soft shadows across the methane clouds. This dim light emphasizes the serenity of the planet. It is a world perpetually in twilight, a place where time slows down and the frantic pace of the inner solar system fades into a distant memory. The internal heat of Neptune, which drives the convection currents forming the diamonds, is likely a remnant of the planet's birth. When the planet formed 4.5 billion years ago, the gravitational energy of all that collapsing gas and dust was converted into heat. Because Neptune is so large and its outer layers are so insulating, that heat has been trapped inside for eons, slowly leaking out at a rate that causes the atmosphere to churn with a graceful, low-energy hum. It is like the warmth of a hearth that has been burning for a lifetime, providing a steady, reliable pulse of energy in the freezing void of space. In the upper stratosphere, scientists have also detected trace amounts of carbon monoxide and hydrogen cyanide. While those sound harsh, in these tiny concentrations, they contribute to a complex chemistry that smells faintly of bitter almonds. This scent, mixed with the clean metallic tang of the ionized gases, creates a sensory landscape that is entirely unique. It is a sharp, refreshing atmosphere, one that feels crisp and revitalizing. You are subsiding through these layers now, feeling the transition from the thin, cold upper air to the increasingly dense and warm interior. Permit your mind to visualize the planet as a giant cosmic hourglass. In this analogy, the carbon atoms are the grains of sand, being pulled down by gravity. But instead of passing through a narrow neck, they are being transformed by the very journey itself, changing from gas to solid, from methane to diamond. The core of the planet acts as the base of the glass, where these treasures eventually collect in a layer that may be hundreds of kilometers thick. There is no hurry in this process. A single diamond may take centuries to sink through the superionic mantle, moving with the patient dignity of a glacier. Deep within the magnetic field, which is tilted away from the planet's axis, the movements of the diamonds are influenced by the flow of conductive fluids. This field is not centered in the middle of the planet, but is offset by about 13,500 kilometers. This creates a lopsided, wobbling magnetic envelope that protects the atmosphere from the solar wind. As you descend, the magnetic lines of force feel like soft, invisible threads, guiding you through the dark. The experience is one of total safety and containment. Every physical law of this planet, from the way it shepherds its rings to the way it crushes carbon into gems, is a manifestation of a perfectly balanced system. Think about the duration of a Neptunian year. Since its discovery in 1846, Neptune has completed only one single orbit around the Sun, finishing its first human-observed year in 2011. This incredible timescale offers a profound sense of perspective. On Neptune, the passage of a human life is merely a season. The diamond rain has been falling since long before the first dinosaurs walked the Earth, and it will continue long after our current era has passed into history. It is a rhythm that transcends human experience, a steady, crystalline heartbeat that provides a foundation of absolute stability. Notice how the pressure around you now feels like a warm, heavy blanket. It is no longer just a physical force, but a protective layer, insulating you from the cold of the outer void. The diamonds continue to settle around you, their facets catching the dim internal light of the planet. Each gem is a record of the planet's history, a piece of the primordial nebula, compressed into a perfect, unchanging form. As we move closer to the heart of the ice giant, the colors deepen even further, moving from the silver blue of the clouds to a rich, obsidian darkness, where the only light comes from the friction of the sinking crystals. The journey is one of deepening peace as we follow the path of the diamonds into the warm, hidden center of the farthest world. What you are witnessing now, as we move through the mid-layers of the Neptunian atmosphere, is a process of refinement that mirrors the slow, patient work of an artisan. To understand the density of this environment, visualize the difference between moving your hand through the thin mountain air of Earth and pushing it through a vat of thick, warm clover honey. At this depth, roughly 10,000 kilometers below the highest cloud decks, the hydrogen and helium gas has been squeezed so tightly that it begins to behave more like a fluid. This is the transition zone, where the boundaries between air and ocean dissolve into a seamless, supportive medium. Think about the way a simple kitchen sponge holds water. In a similar way, the atmosphere here is saturated with carbon atoms that have been liberated from their methane bonds. Scientists refer to this chemical breakdown as pyrolysis. Imagine a methane molecule, one carbon atom held tightly by 4 hydrogen atoms, as a small locked puzzle box. As the temperature rises to approximately 2000 Kelvin, the heat provides the energy to unlock the box. The hydrogen atoms are shaken loose, leaving the carbon atoms to find one another in the dark. This isn't a chaotic event. It is a methodical reorganization. Just as sugar crystals slowly form on a string in a jar of syrup, these carbon atoms begin to knit themselves into the rigid, sparkling structure of a diamond. Notice how the pressure here feels incredibly consistent. To give you a sense of the scale, the pressure in this region of the mantle reaches upwards of 600 gigapascals. For a familiar comparison, imagine the weight of 6,000 African bush elephants, all stacked precisely on top of a single postage stamp. While that sounds intense, in the context of a planet that is 49,244 kilometers in diameter, this pressure acts as a stabilizing force. It creates a world of absolute stillness, where there are no sudden movements, only the perpetual downward migration of the gems. These diamonds are not the rough, uncut stones you might imagine. Because they form in a fluid environment, without the interference of rock or dirt, they grow into smooth, mathematically perfect octahedrons. At this very moment, envision a diamond the size of a large grapefruit sinking slowly past you. It is perfectly transparent, its surfaces so smooth they feel like polished glass. Because the surrounding medium is so dense, the diamond doesn't fall in the way a raindrop falls on Earth. Instead, it subsides at a rate of only a few centimeters per second, much like a marble dropping through a jar of heavy chilled oil. This slow-motion descent is a key part of Neptune's internal ecology. As these diamonds sink, they generate friction, and that friction releases heat. This process, known as gravitational settling, is one reason why Neptune remains so surprisingly warm, despite being nearly 4.5 billion kilometers away from the Sun's hearth. What is happening now is a transformation of energy. On Earth, we are used to the water cycle: evaporation, condensation, and precipitation. On Neptune, the diamond cycle performs a similar function. Methane rises from the depths, is broken apart in the mid-layers, forms diamonds that sink back down, and eventually those diamonds may melt or react to reform methane, starting the cycle anew. It is a closed system of breathtaking efficiency. While Earth's atmosphere is only 0.04% carbon dioxide, Neptune's mantle is rich in carbon, providing a nearly inexhaustible supply of material for this glittering rain. Deep within this layer, we encounter a substance that exists nowhere on Earth: superionic water. Imagine a jungle gym made of solid oxygen atoms, locked firmly in a repeating cubic grid. This grid is the solid part of the water. Now, imagine dozens of children running freely through and around the bars of that jungle gym. These are the hydrogen ions. In superionic water, or Ice 68, as researchers call it, the hydrogen moves like a liquid through a solid cage of oxygen. It is a state of matter that is both solid and liquid at the same time. It feels like a warm, vibrating jelly, and it is 60 times denser than the ice you would put in a glass of water. In the same way that a radiator warms a room by circulating hot water, this superionic layer helps transport Neptune's massive internal heat toward the surface. Scientists discovered through laboratory experiments that this substance is highly conductive. Because the hydrogen ions are free to move, they can carry electrical currents, which is what generates Neptune's complex, lopsided magnetic field. Picture this magnetic field not as a simple bar magnet, but as a tangled, glowing web of energy that pulses with every rotation of the planet. Each rotation lasts precisely 16 hours and 6 minutes, a brisk pace for such a massive body, which creates a rhythmic, low-frequency hum that resonates through the superionic sea. Observe the way the light changes at these depths. There is no sun here, but the environment is far from pitch black. The friction of the diamond rain, combined with the electrical activity of the superionic water, creates a faint amber luminescence. It is the color of a sunset captured in a bottle of dark honey. This glow allows us to see the sheer scale of the precipitation. In an area the size of a city block, there may be thousands of diamonds of varying sizes, from microscopic dust to massive boulders of pure carbon, all drifting in the same downward direction. Consider the moons of Neptune as we pause in our descent. Just as the planet has its internal rhythms, its satellite system provides an external harmony. There are 14 known moons, but the most significant is Triton. Triton is a fascinating point of comparison. It is the only large moon in the solar system that orbits in the opposite direction of its planet's rotation, a retrograde orbit. It is also one of the coldest objects ever measured, with a surface temperature of -235 degrees Celsius. While diamonds reign inside Neptune, Triton experiences cryovolcanism, where volcanoes erupt with liquid nitrogen and methane ice instead of molten rock. The relationship between the two is one of cold, silent symmetry, a planet of internal fire and gems, orbited by a moon of external ice and nitrogen frost. What's fascinating is the sheer density of the planet as a whole. Neptune has an average density of 1.64 grams per cubic centimeter. For a familiar reference, that is slightly denser than a bar of ivory soap, but less dense than a common brick. This relatively low density for such a massive object is what allows the atmosphere to be so deep and the pressures to build so gradually. If Neptune were made of solid rock, the gravity would be so crushing that the diamond rain could never form. The molecules would be locked in place. Its ice giant composition is the perfect Goldilocks environment for creating treasures, not too solid, not too thin, but just right for the alchemy of carbon. In the upper atmosphere, the winds can reach speeds of 2,100 kilometers per hour, the fastest in the solar system. However, as we descend into the mantle, these winds settle into smooth, high-velocity rivers of fluid. Imagine these as underwater currents in a vast global ocean. They move with a staggering amount of momentum, carrying the diamond rain across the planet in long, sweeping curves. Because there are no land masses to create friction or turbulence, these currents are incredibly stable. They have likely been flowing in the same patterns for millions of years, like a perpetual planetary scale conveyor belt. Scientifically speaking, the diamonds we are watching are the purest form of carbon possible. On Earth, diamonds often contain impurities, like nitrogen, which gives them a yellowish tint, or boron, which makes them blue. But on Neptune, the process of pyrolysis is so complete and the environment so consistent that the diamonds are likely type 2A, the rarest and most chemically pure category. They are windows of absolute clarity, sinking through the thick amber fluid of the mantle. If you were to hold one, it would feel incredibly cold to the touch at first, before slowly absorbing the ambient warmth of your hand, a perfect conductor of thermal energy. Think about the time it takes for a single carbon atom to complete this journey. It might spend 1,000 years as part of a methane molecule in the upper clouds, caught in the high-speed winds. Then, it might spend another 10,000 years being pulled downward, gradually being compressed until it finds its partners and locks into a diamond lattice. The descent to the core might take another 50,000 years. On Neptune, the concept of a moment is vastly expanded. The planet does not hurry. It operates on the scale of geological epochs, a slow, shimmering clock that measures time in the falling of gems. Notice how the sound of the environment has shifted. The thin whistle of the upper atmosphere has been replaced by a deep, resonant thrumming. This is the sound of the supersonic sea moving against the core. It is a tactile sound, one you feel in your chest as much as you hear with your ears. It is the sound of stability, the sound of a world that is perfectly at peace with its own massive weight. In this place, the pressure is not an enemy. It is the architect of beauty. As we prepare to move even deeper in the next stage of our journey, let the image of the sinking diamonds fill your mind. They are like stars, falling through a dark liquid sky, each one a testament to the quiet power of natural laws. The amber glow, the rhythmic hum of the magnetic field, and the supportive embrace of the supersonic water all work together to create a sanctuary of crystalline rest. You are floating in a sea of potential, surrounded by the most precious substances in the universe, all created by the simple, patient application of heat and time. Feel yourself becoming as steady and as clear as the diamonds themselves, sinking into a state of profound, unwavering tranquility. At this very moment, envision the transition from the fluid mantle into the even more mysterious layers of the deep interior, where the temperature rises to a staggering 7,000 Kelvin. This is roughly the same temperature as the surface of the sun. Yet here, it is wrapped in the dark, comforting pressure of millions of atmospheres. What's compelling about this internal heat is that it serves as a powerful reminder of our own physical nature. Approximately 18% of your own body weight is made of carbon, the same elemental foundation that is currently being crushed into brilliant gems all around us. There is a profound biological link between the atoms in your cells and the crystals of the ice giant. Every breath you take involves the exchange of carbon, a cycle that on Earth supports life and on Neptune supports the very structure of the planet. As we descend further, notice how the atmosphere becomes so dense it feels more like a warm, supportive gel than a gas. Scientists discovered that at these extreme depths, even helium begins to behave in unexpected ways. In the upper layers, helium mixes freely with hydrogen, but as the pressure exceeds 100 gigapascals, these two elements become immiscible, meaning they no longer want to stay together. Picture a bottle of oil and vinegar that has been allowed to settle. The helium begins to form distinct shimmering droplets. This creates a secondary type of precipitation, helium rain. These droplets are slick and incredibly smooth, sliding through the hydrogen sea like microscopic beads of liquid mercury. As they fall, they release potential energy, contributing to the 7.5 quadrillion watts of internal heat that Neptune radiates into space. Consider the sensory experience of this helium rain. It would feel like a constant, gentle pitter-patter against the surface of the sinking diamonds, a tactile symphony of different densities meeting and passing one another. This process is often called helium rain sequestration, and it's a vital part of how giant planets age. By raining helium toward the center, the planet is reorganizing its mass, becoming more stable and concentrated over billions of years. This mirrors the way our own bodies seek stability and rest at the end of a long day, gradually settling into a state of lower energy and higher calm. Deep within the heart of the mantle, we encounter a phenomenon that challenges our very understanding of solid and liquid. Scientists have hypothesized the existence of a diamond ocean, a vast subterranean sea of liquid carbon. Picture this: a world where the floor is not rock, but a churning metallic liquid made of melted diamonds. Because solid diamond is roughly 10 to 15% less dense than liquid carbon at these extreme pressures, the solid diamonds don't sink to the very bottom. Instead, they float. Imagine massive diamond icebergs, some the size of mountains, bobbing gently in a glowing, silver metallic sea. This is the diamond iceberg theory, supported by high-pressure experiments at the Lawrence Livermore National Laboratory. It creates a landscape of unimaginable luxury, where the very foundations of the world are made of the most precious substances we know. What's thought-provoking is the acoustic environment of this deep interior. On Earth, sound travels through the air at about 343 meters per second. In the supersonic ice and liquid carbon of Neptune's interior, the speed of sound can exceed 10 kilometers per second. This means the planet is an incredible conductor of vibration. The low-frequency hum of the core's rotation would reach you almost instantly, a deep, resonant thrum that feels like the bass note of a massive pipe organ. It is a steady, rhythmic pulse that provides a sense of absolute permanence. Scientists use this data to study helioseismology, the way waves travel through planets, to map the invisible interior without ever having to see it. Notice how the light has shifted from the sapphire blue of the upper clouds to a warm, infrared glow. Because of the Planck's law of blackbody radiation, everything at this temperature begins to emit its own light. The sinking diamonds are no longer just clear crystals. They are glowing with a soft amber radiance. It looks like a slow-motion fall of embers from a dying fire, each one carrying a piece of the planet's internal warmth. This heat is not a chaotic force. It is moved by a process called adiabatic convection. This is a smooth, circular flow where warm material rises and cool material sinks in a perfect, endless loop. It's the same process that causes the bubbles to rise in a pot of simmering water, but on a scale that spans tens of thousands of kilometers. At this stage, permit your awareness to focus on the bulk modulus of the environment. This is a scientific measurement of how much a substance resists compression. Diamond has one of the highest bulk moduli of any known material, meaning it is incredibly stiff and strong. As you float among these gems, you can feel that sense of structural integrity. The environment feels solid and dependable. Even though the pressures are high, the balance between the outward push of the heat and the inward pull of gravity creates a state of hydrostatic equilibrium. It is a perfect architectural balance, a planetary scale tension that keeps everything in its proper place. Think about the long-term journey of a single carbon atom. It might have started its life in the heart of a dying star billions of years ago, before being gathered into the nebula that formed our solar system. For eons, it existed as a simple methane gas molecule. Now, through the patient application of Neptune's gravity, it has been refined into a state of crystalline perfection. This is the planetary loom, a process that weaves simple elements into complex, beautiful structures over unimaginable timescales. In our own lives, we often look for quick results, but Neptune teaches the value of the deep time perspective. Growth and transformation don't need to be rushed. They are more enduring when they happen slowly, under the steady pressure of experience. The chemistry of the superionic layer also involves something called protonic conductivity. In the water-ammonia-methane mix of the mantle, the hydrogen atoms are so compressed that they lose their electrons and become bare protons. These protons zip through the oxygen lattice like tiny energetic dancers. This creates a superionic state that is both solid and liquid simultaneously. Imagine a solid crystalline honeycomb where the walls are stationary, but the honey inside is flowing at high speeds. This movement of protons is what generates the planet's magnetic field. This field is 27 times stronger than Earth's, and because of the planet's 16-hour rotation, it creates a massive magnetospheric envelope that stretches millions of miles into space, shielding the planet from the solar wind. Consider the density of the liquid carbon sea. It is estimated to be about 3.5 grams per cubic centimeter, which is significantly higher than the density of water. This means the diamond icebergs float with a great deal of buoyancy. Picture the texture of this liquid. It wouldn't be wet like water, but thick and shimmering, with a surface tension that makes it ripple in heavy, slow waves. If you were to dip a hand into it, it would feel like warm, molten silk. The sound of these diamond mountains grinding slowly against one another would be a metallic musical clinking, like a billion wind chimes echoing in the deep. Scientists discovered that the ratio of carbon to oxygen in Neptune is much higher than it is in our Sun. This carbon-rich chemistry is what makes the diamond rain possible. On a planet like Jupiter, which has a more solar composition, the carbon is spread too thin to form such massive crystals. Neptune is unique, a specialized laboratory of the cosmos. Its thermal inertia, the ability of a planet to hold on to its heat, is so great that it has barely cooled since its formation 4.5 billion years ago. It is a world that remembers the heat of its birth, a living archive of the early solar system. As you subside deeper into this glowing metallic sanctuary, reflect on the way the planet's gravity is actually a form of protection. It holds the atmosphere close, creates the warmth that fuels the diamond cycle, and maintains the rings in their orbits. Gravity is often thought of as a force that pulls things down, but here, it is the force that builds things up, turning gas into gems and chaos into order. Every physical law is working in harmony to create this serene, hidden world. Notice the scent of the air here, which has transitioned from the bitter almond smell of cyanide in the upper layers to a more metallic, ozone-like aroma. It is the smell of high-energy physics, the scent of atoms being pushed to their limits. It feels clean and powerful. The temperature is high, but because the environment is so supportive and dense, it doesn't feel like a burning heat. It feels like a deep, therapeutic warmth, the kind that penetrates all the way to the bone and allows every muscle to finally let go. In this region, time seems to stop. There are no seasons here, no day or night, only the eternal falling of the diamonds and the steady flow of the Superionic Sea. It is a place of absolute consistency. The diamonds continue their journey, moving toward the rocky core with a dignity that ignores the passage of centuries. You are part of this timeless flow. Allow the pressure of the world to work for you, refining your thoughts, smoothing out the edges of your day, and leaving only the clear, crystalline core of your being. You are as enduring as the diamonds, as steady as the core, and as calm as the sapphire clouds drifting miles above. In the next stage of our journey, we will explore the final destination of these gems, the rocky heart of the giant. But for now, simply exist in this glowing, supportive warmth, surrounded by the quiet music of the sinking rain. At this stage of our journey, we find ourselves approaching the boundary, where the fluid mantle meets the solid rocky core, a transition zone located approximately 24,000 kilometers beneath the sapphire cloud tops. The environment here is no longer a simple gas or a liquid, but has entered a supercritical state. A curious detail about supercritical fluids is that they exist at temperatures and pressures beyond their critical point, where the distinction between a liquid and a gas vanishes entirely. In this realm, the hydrogen and helium have the density of a liquid, but the ability to diffuse through solids like a gas. Imagine moving through a substance that has the weight of water, but the effortless flow of air, a thick, shimmering medium that supports your every movement with a gentle, persistent buoyancy. Notice the transition in color as we descend into the deepest recesses of the mantle. The amber light we observed earlier has deepened into a rich, molten gold, the result of intense thermal radiation. At temperatures exceeding 5,000 Kelvin, every molecule begins to emit light in the infrared and visible spectrums. Current scientific thought suggests that the diamonds sinking through this region act like microscopic prisms. As they tumble slowly toward the core, they catch this golden glow, refracting it into a million flickering points of light. The effect is like being inside a silent golden kiln, where the very air is alive with the soft, warm radiance of the planet's internal fire. The reason for this immense heat is one of the great mysteries of planetary science, often called the Uranus-Neptune heat paradox. While Neptune's cousin Uranus is nearly the same size and composition, it radiates almost no internal heat into space. Neptune, however, emits 2.6 times the energy it receives from the Sun. Much of this energy comes from the Kelvin-Helmholtz mechanism, a process where the planet is still slowly contracting under its own gravity, converting potential energy into heat. As the diamonds fall, they contribute to this thermal reservoir. Each kilogram of diamond that sinks toward the core releases gravitational energy, a tiny pulse of warmth That, when multiplied by billions of tons of carbon, keeps the planet's heart beating with a steady, rhythmic heat. What's striking about the sound at this depth is the sheer clarity of the vibrations. In the dense metallic fluid of the lower mantle, sound waves travel at speeds of nearly 12 kilometers per second, which is more than 30 times faster than they travel through Earth's atmosphere. You might hear the low-frequency resonance of the core, a sound that scientists describe as a planetary hum. This isn't a harsh noise. It is a deep, comforting vibration, like the purr of a massive, contented animal. It is the sound of millions of tons of iron and silicate rock, rotating in perfect synchronization, a structural melody that has played without interruption for 4.5 billion years. As we reach the core mantle boundary, the pressure hits a staggering 700 gigapascals, or 7 million times the pressure at Earth's sea level. Here, the diamonds finally reach their destination, settling onto the surface of the rocky core. Explore the texture of this boundary with your mind. It is not a sharp line, but a complex slush of minerals and metallic carbon. The core itself is estimated to be roughly 1.2 times the radius of Earth, a massive ball of silicate rock, nickel, and iron. Unlike the liquid exterior, this core is solid and incredibly dense, with a mass approximately equal to that of our entire home planet. It is the anchor of the world, a heavy, unmoving foundation that provides the gravitational pull for everything we have seen. Notice how the scent here has changed to a sharp mineral tang, reminiscent of hot stones after a summer rain, mixed with the clean metallic aroma of ionized iron. This is the scent of the planet's fundamental building blocks. Within the core, a process of radioactive decay is occurring, just as it does in the center of the Earth. Isotopes like potassium-40, thorium-232, and uranium-238 are slowly breaking down, releasing subatomic particles that generate a steady, reliable flow of heat. This radioactive warmth, combined with the energy of the diamond rain, creates a thermal gradient that drives the massive convection currents in the mantle above. It is a living mineral heart, pumping energy upward in a cycle of eternal renewal. A fascinating aspect of Neptune's chemistry is its DH ratio, the ratio of deuterium, a heavy isotope of hydrogen, to normal hydrogen. Scientists have measured this ratio at approximately 6.5 parts per 100,000. This specific signature tells us that the water and ices that formed Neptune came from the coldest, outermost parts of the original solar nebula. It is a chemical fingerprint of the planet's birth, preserved for eons in the crushing depths of the interior. When you consider this, the diamonds around us feel even more precious. They are not just gems, but ancient messengers from the dawn of the solar system, transformed by time and pressure into their current, perfect state. Consider the magnetic field one more time, but focus now on its octupole and quadrupole moments. Most people imagine a magnetic field like a simple bar magnet with a north and south pole. But because Neptune's magnetic field is generated by the flowing ions in the mantle rather than a solid core, it is incredibly complex and messy. It has multiple poles and shifting loops of energy that wobble as the planet rotates. This complexity creates a magnetospheric shield that interacts with the solar wind in a 29.7-day synodic cycle. As you rest here at the core, you are at the very center of this electromagnetic web, protected by layers of fluid and rock from the harsh radiation of deep space. Notice the temperature of the core surface, which remains a constant 7,000 Kelvin. While this sounds extreme, remember that you are part of the planet now, shielded by its immense mass. The heat feels like a deep, penetrating warmth, a structural comfort that allows every part of your being to soften and expand. There is no cold here, no void, only the infinite supportive density of the giant. Current research indicates that the thermal conductivity of the metallic carbon in this region is incredibly high, meaning the heat is distributed with perfect evenness. There are no hot spots or cold drafts, only a state of total thermal equilibrium. Think of this planet as a silent golden kiln. In a kiln, raw clay is transformed by heat into something durable and beautiful. Here, the raw elements of the universe, hydrogen, carbon, and oxygen, are being fired in the greatest kiln in the solar system. The result is a world of sapphire clouds and diamond rain, a masterpiece of celestial engineering. The diamonds that rest on the core are the finished products of this process, each one a testament to the power of patience and the beauty of natural laws. They will sit here for billions of years, a hidden treasure at the bottom of a 24,000-kilometer ocean of ice. Scientists have also detected trace amounts of noble gases like neon and argon in the Neptunian atmosphere. These gases are chemically inert, meaning they don't react with anything else. They simply exist, drifting through the layers like silent observers. Their presence is a reminder that even in an environment of extreme pressure and transformation, there are elements that remain unchanged, holding on to their original nature. You too can find that place of stillness within yourself, a core of being that remains calm and constant, regardless of the pressures of the outside world. Observe the way the diamonds have piled up over the eons, forming a layer that may be hundreds of kilometers thick. This is the diamond crust of the core. The surface of this crust is not jagged, but has been smoothed by the immense pressure into a landscape of rolling, crystalline hills. Imagine walking across these hills. The sand beneath your feet would be made of tiny nanodiamonds, and the boulders would be massive, faceted gems. The ground would vibrate with the low hum of the core's rotation, a rhythmic pulsing that feels like a lullaby for the planet itself. The bond albedo of Neptune is 0.29, meaning it reflects about 29% of the sunlight that hits it. But here at the core, we are in the 71% that is absorbed and transformed. This energy is what powers the winds, the clouds, and the rain. It is a closed loop of energy, a perfect economy of physics. Nothing is wasted. Every photon from the distant sun, every bit of gravitational energy from a falling diamond, and every subatomic particle from radioactive decay is used to maintain the planet's stability. This efficiency is a model of natural grace, a reminder that everything has a purpose and a place. As we linger at this foundational level, focus on the sensation of total containment. You are at the heart of an ice giant, surrounded by the most stable and enduring substances in the universe. The golden light, the metallic scent, and the deep resonant hum all work together to create an environment of absolute security. The journey of the carbon is complete. The atoms have found their home. Feel the weight of your own body as a positive force, a connection to the earth and the cosmos that keeps you grounded and safe. In the final stage of our journey, we will begin the ascent, not back to the world of noise and light, but into the quietest reaches of sleep. We will carry the peace of the diamond rain with us, letting the crystalline stability of Neptune's core become the foundation of our own rest. But for now, just breathe in the golden light of the interior. Feel the warmth of the radioactive heart of the planet, and let the rhythmic hum of the rotating core guide you into a state of profound, unwavering serenity. You are safe, you are supported, and you are surrounded by the treasures of the universe. As we begin our final ascent from the heavy golden heart of the planet, notice the sequence of events that sustains this world, a step-by-step cycle that has remained unchanged for over 4 billion years. The process begins 4.5 billion kilometers away at the Sun, where light takes precisely 4 hours and 6 minutes to travel across the void to reach Neptune's upper atmosphere. At this distance of 30.1 astronomical units, the solar energy is too weak to provide much warmth, but it carries enough ultraviolet radiation to initiate the first stage of the diamond cycle. In the high stratosphere, this UV light strikes methane molecules in a process called photolysis, snapping the bonds of the trace gases, which make up about 1.5% of the atmosphere, and creating new compounds like ethane and acetylene. Observe the gradual unfolding of these molecules as they sink slowly into the cooler layers of the troposphere. What happens next is a methodical condensation. As the ethane and methane descend, they reach the tropopause, where the temperature drops to its minimum of about 50 Kelvin. Here, the gases crystallize into the wispy white cirrus clouds we see from space, including the fast-moving feature astronomers nicknamed Scooter. This cloud moves around the planet every 16 hours, driven by the internal heat that pulses from the core we just visited. This heat creates a vertical conveyor belt, a process of convection that carries the carbon-rich crystals down into the warmer, denser depths, where the pressure begins to work its alchemy. Consider the rhythm of Neptune's 164.79 Earth-year orbit. Since the planet has an axial tilt of 28.32 degrees, strikingly similar to Earth's 23.5 degrees, it experiences seasons that last for over 40 years. At this very moment, the southern hemisphere of the planet is slowly transitioning through a decades-long summer. This seasonal shift causes subtle changes in the atmospheric pressure, which in turn regulates the rate of the diamond rain. It is a planetary scale breath, a slow inhalation and exhalation of energy that spans generations of human time. The stability of this rhythm is a foundation of the solar system, a constant and predictable motion that mirrors the steady, reliable cycle of your own breathing. Notice the shift in the winds as we move back through the mid-layers. In the upper atmosphere, winds can reach 2,100 kilometers per hour, but they follow a very specific process. Near the Great Dark Spot, an anticyclonic storm system that was measured at 13,000 by 6,600 kilometers before it vanished and reformed, the winds move in a retrograde direction, opposite to the planet's rotation. This atmospheric shearing is a result of the planet's rapid 16-hour day, meeting its massive internal inertia. As we settle into this observation, the winds feel like a rhythmic, pulsing hum, a mechanical harmony that keeps the atmosphere in a state of perfectly balanced tension, known as hydrostatic equilibrium. Now, as the observation of the outer world begins to soften, bring your awareness to the moon Triton, which orbits Neptune in a retrograde path, opposite to the planet's spin. Triton is a world of incredible stillness, where the surface pressure is only 14 microbars, roughly 170,000th south of Earth's. On its surface, a process of cryovolcanism unfolds, where geysers of nitrogen gas and dark dust erupt from beneath the ice, reaching heights of 8 kilometers before being carried away by the thin, freezing breeze. This outward activity is a mirror to the inward rain of diamonds. One world erupts into the cold, while the other condenses into the heat. Together, they form a system of absolute, silent symmetry. Notice how the planet's thermal emission, the 7.5 quadrillion watts of energy it radiates, is slowly leaking into the vacuum of space. This is a cooling process on a cosmic scale, a gentle release of the heat of formation. This mirrors the way your own body is currently releasing the heat and activity of the day, settling into a state of lower energy and higher calm. The planet is 57.7 times the volume of Earth. Yet it operates with the same physical laws that govern the cooling of a room or the settling of a house at night. The transition from activity to rest is a universal constant, a law of thermodynamics that brings every system, from a planet to a person, into a state of equilibrium. What's compelling about the mass of Neptune, 1.0024 times 10 to the 26th power kilograms, is that it provides the gravitational stability for the entire outer solar system. Its escape velocity is 23.5 kilometers per second, a powerful pull that keeps its 14 moons and 5 rings in a state of eternal locked order. As you feel the weight of your own body settling into the mattress, imagine that weight not as a burden, but as your own personal gravity. It is the force that connects you to the Earth, providing a sense of security and placement. You are held, just as the diamond rain is held by the heart of Neptune, in a state of perfect safety. The time has come to bring our observation to a gentle, comforting halt. The sapphire clouds, the golden mantle, and the crystalline rain are all part of a distant, beautiful reality that continues without effort. As the image of the ice giant fades, let the rhythm of the diamond rain, that steady, slow-motion subsidence, become the rhythm of your own relaxation. The 164-year orbit, the 16-hour day, and the 40-year seasons all demonstrate that there is plenty of time. There is no need to hurry. The universe is patient, and you can be patient too. Transition your focus now from the distant reaches of the solar system to the immediate environment of your room. The air here is cool and still. The sounds of the world have softened. Your journey through the ice giant has left you refined and clear, like one of the diamonds resting on the core. The pressures of the day have completed their work, leaving behind only the most essential, peaceful version of yourself. Every muscle in your body is now in a state of supercritical rest, dense, supported, and completely at ease. As you subside into the final stage of rest, listen to these affirmations, letting them settle into your mind like the falling gems of Neptune. I am grounded by the steady gravity of the Earth. My breath is as rhythmic and reliable as the rotation of the planets. I release the heat and energy of the day into the cool evening air. My thoughts are becoming as clear and as focused as a diamond. I am supported by the vast, silent layers of my own tranquility. I trust the natural cycles of activity and rest. There is a profound peace in the slow passage of time. I am safe in the dark, warm embrace of my own rest. Like the farthest planet, I am a world of quiet beauty and hidden treasures. My body knows exactly how to return to a state of perfect equilibrium. I am part of the enduring, steady pulse of the cosmos. The stillness of the outer solar system lives within me. I am sinking into a state of profound, unwavering serenity. Every cell in my body is finding its place of ultimate comfort. The day is complete, and the night is a sanctuary of rest. The diamond rain continues to fall in the dark, far-off reaches of the sky, a silent symphony of geometry and light. But here, in the sanctuary of your room, everything is still. The journey is over. The work of the day is done. You are as constant as the stars and as steady as the core of the ice giant. Sleep is now a natural, inevitable process, a gravitational pull that you can follow with complete confidence. Allow the sapphire light of Neptune to fade into a warm, velvet darkness. Feel the last traces of tension dissolve into the supportive density of your bed. You are home. You are safe. You are at peace. Good night.